Welcome to your first organic chemistry naming video. In order to name anything in organic chemistry, you first need to know your prefixes. So, if you have one carbon, what is the prefix? It would be meth. If you have two carbons, it would be eth. 3 carbons is prop. 4 is bute. 5 is pent. 6 hex. 7 hept. 8 oct. 9 non. And 10 is dec. Okay, cool. So knowing that, now let's go with the endings here. We're going to deal with the simplest form of these organic compounds. So we've got things called alkanes, which are also known as paraffins. Alkanes follow the formula of CnH2n plus 2. You're going to want to know that these guys are referred to as saturated. And that has to do with how many hydrogens have been fit in. These guys have as many hydrogens as carbon could possibly have. When we draw these out, that'll make a little more sense. So alkanes have the ending of ane. So let's practice here. If I have methane, how many carbons is that? It's 1 carbon. And then plug in 1 for N. How many hydrogens is that? It would be 4. Okay, what about ethane? Ethane, what would that be? C2H6. So you could be asked a question like, what is the formula for methane? What's the formula for pentane? What's the formula for decane? Or you could be asked, what is the name of C9H20? So you're going to want to be able to use this formula up here as well as these prefixes. Before we fill in the rest of this chart, let's do alkenes and alkynes. Alkenes, they follow the formula CnH2n. These guys are unsaturated. And the reason for that is a spot where a hydrogen could usually fit has been removed because now we have 1 double bond. So let me change my color here. So alkanes are all single bonds. Alkenes have 1 double bond. And then we're going to deal with alkynes next, which are going to have 1 triple bond. Let's go ahead and take care of that now. So, alkenes, what's the ending for an alkene? But you can't guess. Yeah, it's ene. So then we have alkynes, which have the formula CnH2n minus 2. So we've got alkenes that are CnH2n. If you go to the left, it's plus 2. If you go to the right, it's minus 2. You can think of them linked that way. This is also unsaturated because it does not have the maximum number of hydrogens bonded to those carbons. And it's got an ending of ine. So we could have methane, methene, methene. Could we have methene? Can you have a double bond when you only have one carbon? No, there's nothing for that carbon to bond to with a double bond. Those hydrogens won't do it, so that's not going to happen. However, you could have ethene. So ethene, 2 carbons. How many hydrogens? 2 times 2 is 4. What about ethyne? Ethyne, just C2H2. So what you could do right now if you want is pause the video and fill in the rest of this chart, then come back and see if what you've got matches what I've got. I'm going to quickly fill these in. Here we go. Whoop, C3H8, C4, oops, that's a 4, H10, C5, H12, 6, H14, H16, 18, 20, and of course if you're sitting here watching me count these up, you could always like skip ahead if you are like, oh, I've got this, I'm a pro now. All right, here we have C2H4, C2H6, whoops, not 2, 3H6, C4H8. I like these are the easiest to calculate. H10, because you just double the number of carbons. C7, H14, C8, H16, C9, H18, and C10, H20. Hopefully we won't have carpal tunnel by the time this is over. C3, H4, C4, H6. You're probably starting to see a pattern here. It's going up by 2 hydrogens each time, which is nice. C8, H14, C9, H16, and C10, H18. Whew! Okay, so now that we have all of that written down, I'm going to give you a chance to practice some problems that would reference this material. So take a good look at this. I hope you wrote it down. And whoop, it's gone. Okay, so if I give you the formula C3H8, what is the name of this compound? This would be, well, we've got 3 carbons, so we know it's prop. But now we have to figure out if it's ane, ene, or yne. So 3 times 2, we know it's always times 2. 3 times 2 is 6. And then we know 6 plus 2 is 8. And we know, okay, when we have 2n plus 2 for the hydrogens, that's an ane ending. So this is propane. That's how you'd figure this out. You'd say 8 is equal to 3 times 2 plus 2, which means ane. Okay, what if you had C7H12? If you said hept-yne, you would be correct, because here we've got 7 times 2, which is 14, minus 2 equals 12. When you have to subtract 2, that means it's got the yne ending. Okay, what if I asked you a true or false question and I said C6H12 contains only single bonds? True or false? The correct answer would be false. So I'll write this out. Contains only single bonds? Question mark. No. And the reason for that is it has the ene formula, which means it has one double bond. So let's try that again. Let's say C9H20. What kind of bonds does this contain? Is it all single? Does it have one double, or does it have one triple? This would be, and if you need more time, just pause, this would be all single bonds. Okay, what about if I gave you C3H4? Is it all single, one double, or one triple? This one has one triple. It follows the yne formula. Okay, what if I asked you, out of the ones that I've already put onto this page, which ones of these are saturated? Which are saturated? Anything with an ane ending or single bonds is saturated. So you would have wanted to say that. Propane is saturated. And what's this one? What's this called? This is non-ane is saturated. So that means that heptyne is unsaturated, us. And then what's C6H12? What's the name of that? It's hex what? Hexene, because it's got a double bond. And this one is also unsaturated. Both double bonds and triple bonds make something unsaturated. And then finally C3H4, what's the name of that? Prop, because of 3 carbons. Yne, because it has a triple bond, and it's unsaturated. All right, there's another type of problem that you could get that references this concept. Okay, if I give you this, actually I'm going to draw a few of these out. So here's one of them. I want you to try naming these. So you're going to name that one. And this one. And this one. You should name these guys. You should also label them as saturated or unsaturated. Whoa, whoa, whoa. And finally, let's name this one. So name these guys and label them as saturated or unsaturated. I'm trusting you to pause and figure that out. So now I'm going to give you the answers. Here we have 1, 2, 3, 4 carbons and no double or triple bonds. So this guy is butane and it is saturated. Here we have 3 carbons, so you should have had prop. And oh, it's got a double bond, so it's propene. And this one is unsaturated because it has a double bond in there. Here we have 1, 2, 3, 4, 5, 6, 7. We have 7 carbons, so this is hept. And there's a double bond, so it gets the ene name. and since it has a double bond in there, it's unsaturated. And finally, even though this is curved, it's still a long chain of 1, 2, 3, 4, 5, 6, 7. Ooh, another 7 one. Hept, and then a triple bond. So hept, yne, and since it's got that triple bond, it is again unsaturated. Something you should notice, because you're going to have to be able to draw these too. Notice that these carbons do not have more than 4 bonds on them. So carbon forms a max and min, actually, of 4 bonds. It forms exactly 4 bonds. So the final exercise we're going to have, I don't know if I said this was final, but sorry, I lied. The final exercise is you drawing some. So let's try it. How about, let's have you draw non-ene butene and hexane, and then label them as saturated or unsaturated. So pause and do that, and then come back. Okay, non-ene has 9 carbons and it has a double bond. So 1, 2, 3, 4, 5, 6, 7, 8. I don't want this to smash over there. 9, and it's got a double bond, and we're just going to go ahead and put our double bonds on the end. So there it is. And then everything else needs to be a hydrogen. I am going to use a shortcut that's commonly used, which is leaving off the H from the hydrogens. But just know at the end of each of those lines is an H. Now make sure when you drew this that you only put 4 bonds on each carbon. 1, 2, 3, 4, 1, 2, 3, 4. All of them should have 4. And this guy is unsaturated because it has a double bond. All right, your butene should have had 4 carbons. It does not matter which end the triple bond is on, as long as it's on an end for this class. We're not going to deal with mixing in those double bonds and this one, or triple bonds. You can, but we're not going to. And then hexane would be 6 carbons. If you're curious, you can ask me. I'll tell you how to name them. 1, 2, 3, 4, 5, 6. Hexane, only single bonds, and then each carbon needs 4 bonds coming off of it, so the rest of that space is going to get filled up with hydrogens. Whew, there you go. All right, so that's the end of our first video. Next time we're going to deal with some simple side groups like methyl, ethyl, bromo, and so on.